is your lesson for 3-4 dividing polynomials. The explore and reason here, which is located in your student companion, that is something that you will be completing online, and answers to that will be posted in Schoology a little bit later on. So your essential question, how can you divide polynomials? We're going to look at two different ways to divide polynomials. These are not as straightforward as the adding, subtracting, multiplying is. This does involve a different process. The first process we are going to look at uses long division. So if you recall, long division, that's actually what your explore and reason focused on. That's where you take the number on the outside, you divide it into what's on the inside of your division bar, and then you deal with remainders and all that kind of stuff. And we're going to be doing the same thing with our polynomials. So it says, how can you use long division to divide p of x and d of x? And then we need to write the polynomial p of x in terms of the quotient and the remainder. So the quotient is what you get when you divide, and then we are going to have a remainder left over. So d of x, the x plus 3, that is my divisor. That is going to go on the outside of my division setup. My p of x, the x cubed plus 5x squared plus 6x plus 9, that goes on the inside of the division setup, and that is called the dividend. So this is where we're going to be starting. Just like you would do if you had numbers, you are going to divide the term that is on the outside. So in this case, I'm actually only going to be looking at the x into the x cubed. So you're basically going to be simplifying that fraction. X cubed over x simplifies to x squared. So I am going to write an x squared, and I'm actually going to keep everything lined up. So I'm going to put the x squared over top of the other x squared. And then again, just like you would do if you had numbers, you're going to take that x squared and you're going to multiply it by the x and by the 3. So x squared times x is x to the cube, or x to the third power, x cubed. X squared times your plus 3 is a plus 3x squared. Now, if you recall, whenever you do division, typically we subtract those terms. And I'm going to be doing the same thing here. X cubed minus x cubed, that is gone. If that does not disappear completely, that means that you have the wrong term on the top that you picked for part of your quotient. So next I have 5x squared minus 3x squared, which is 2x squared. And then just like we would do with numbers, I'm going to bring down the next term, which is the plus 6x. So then we take the x squared, or I'm sorry, the x on the outside into the 2x squared. So I'm going to be simplifying this fraction, 2x squared divided by x. Well, 2x squared over x simplifies into 2x, and it is positive, so I'm going to put a plus 2x on the top. And then I'm going to multiply that 2x by the x and by the plus 3, just like we multiplied for the previous step. 2x times x is 2x squared. 2x times 3 is 6x, and we are going to be subtracting. Well, 2x squared minus 2x squared, that's gone. 6x minus 6x is also gone. I do have the 9 that I have to bring down. We'll draw in here so you can see that gets brought down, that gets brought down. And you are done dividing when your fraction has a bigger x in the bottom than it does in the top, because x into the 9, that's really looking at 9 over x, and we can't do anything with that because you have a bigger x exponent in the bottom than you do in the top. If they're equal, if you had something with an x over something with an x, then that's fine. But because this one has the bigger x on the bottom, we're now finished. 9 is our remainder. It's our remainder. It's what's left over. So my final answer, whenever I divide p of x by d of x, is going to be x squared plus 2x. And then to write the remainder, you are going to write it as a fraction instead of just writing remainder 9, you're going to write plus 9 over the original divisor, which is x plus 3. And we will be writing using the same format even when we look at our next method, which is synthetic division, which doesn't involve quite as many steps as long division does. So our next example, we have 8x cubed plus 27 and then 2x plus 3. So 2x plus 3 is going to go on the outside. The 8x cubed plus 27 goes on the inside, but there is something that we have to add into this. Because I do not have every exponent starting at 3 counting down to 0, I do need to put zeros in where I am missing terms so that we keep our place value. So the 8x cubed is going to be fine. We can put that one in there. Then we're going to have 0x squared, and then a 0x, and then a 27. So notice I was missing an x squared, I was missing an x, so I went through and put in zeros for both of those terms. So now we're going to start our long division process. 2x into 8x cubed. So 8x cubed over 2x, that's going to simplify to 4x squared. So I'm going to put that over top of the other squared term, and then I'm going to multiply. So I get 8x cubed plus 12x squared. We are subtracting. The 8x cubed minus 8x cubed is gone. The 0x squared minus 12x squared is a negative 12x squared. Please make sure you are subtracting both terms that are in the parentheses there. Now I bring down my next term, which is the 0x. 2x into the negative 12x squared. That's going to be a negative 6x. So again, I multiply that one. Negative 6x times 2x is negative 12x squared. Negative 6x times negative 3 is negative 18x. And again, I am subtracting. The first term is gone. 0x minus negative 18x is a positive 18x. Then I bring down the plus 27. 2x into the 18x goes 9 times. So 18x over 2x, that goes 9 times. 9 times 2x is 18x. 9 times 3 is 27. When we subtract, they are both gone. So this one actually has no remainder. When you divide and your term has no remainder, that means that your divisor is a factor of your original dividend. So 2x plus 3 is a factor. And you should recognize this because 2x plus 3, that's actually, well, the 8x cubed plus 27, that's actually a sum of cubes. And 2x plus 3 is the first factor of any sum of cubes. So you may have recognized that before I actually got down through to the final answer there. Now, there is an easier method in a lot of cases, and that's called synthetic division. Synthetic division is only something you can use when your divisor is a linear expression. So with the example where we had the 2x plus 3, and even the first example, we could have used synthetic division for those. Synthetic division is the main method I'm going to have you guys practice, but I did want to introduce long division so that you had an idea of what that was about. So you do need to make sure that whatever you're dividing is in the form x minus a. Again, a can be positive or negative, but it is going to be opposite whenever you put it in the box using the setup that we have for example 2. If it's not in that format, you do have to divide everything by the number that's in front of the x term. So just be aware that that has to happen. Okay, so example 2. What is 2x cubed minus 7x squared minus 4 divided by x minus 3? and we are going to use synthetic division. To figure out the number that goes in the box, you're going to take your divisor, and you're basically going to solve that. So it's going to be opposite. So if my divisor is x minus 3, positive 3 goes into the box. You should note that there is a 1 in front of the x, so I don't have to do any other overall dividing to make that into something that I can work with. You will hopefully see an example of how that works. If not, I'm sure I can pull up a Khan Academy video so you can see how that would go through. Next, we are going to take the coefficients of our polynomial. If you are missing any coefficients in sequence from highest to lowest, then you do need to put in zeros. So my first coefficient is a 2. My second coefficient is a minus 7. I am missing the x term, so that is going to be a 0. And then I have minus 4 as my constant term. Notice I want to leave a row underneath those numbers so that I can write in, there's other numbers that are going to be going there. So here's the process once you have this set up. The first number goes down below the line. You take that number, multiply it by what's in the box. So 2 times 3 gives me a 6. I put that in the next column, and then I add down. Negative 7 plus 6 is negative 1. Repeat the process until you're finished. I take my negative 1, multiply by the 3, I get a negative 3. Add those together, 0 plus negative 3 is negative 3. Now I do negative 3 times 3, which is a negative 9. Add those together, and I get a negative 13. Those numbers represent the coefficients of your answer. You do have to put them back into polynomial form. To figure out the polynomial form, you want to look at your original problem, and the first term there is 2x cubed. You want to take that exponent and knock it down by 1. It was divided by an x to the first power, which means the highest term is now going to be an x squared. That is going to be your coefficient for your first term. So the 2, it's the farthest number to the left. That is going to be the coefficient for the x squared term. And then I go down in sequence until I get to my remainder. The minus 1 is going to be the coefficient for the x term. The minus 3 is my constant term. And then the negative 13 at the end is my remainder. So that's going to be minus 13 over the original divisor of x minus 3. And that is my solution using synthetic division. I'm going to stop this video here just so it doesn't get too incredibly long. Please go back and rewatch anything that you're not sure of. And be sure to watch the second part video so you can continue with your understanding of synthetic division and its application.